Hello students, in this video we are going to solve exercise page 151 number 9. ABC is an isosceles triangle of vertex A. So first let's draw this isosceles triangle. No measures are given, so we draw first the base BC of length, random length, as much as we want. Then we draw two arcs of same radius, of course different than BC. These two arcs will intersect at A, and the arcs must have B and C as their center, of course. I is the midpoint of BC. To find the midpoint of BC, we measure BC with our ruler, find its half, then we locate I midpoint of BC, or on your copybook you can count the squares and find their half. Of course, segments IB and IC are equal midpoint effect. P is a point of BI, P is a point on BI, and Q is a point on segment CI, such that BP equals CQ. So BP equals CQ, it's given. So first we place point P on BI wherever we want. It's not the midpoint of BI, they didn't mention it. Then using our compass, we can open it equal to BP, put the needle on C, then find point Q, such that BP equals CQ. First question, prove that I is the midpoint of segment PQ. Question 1, prove, underline I midpoint of PQ. So we need to prove that I midpoint of PQ by proving that the two segments IP and IQ, are they equal? Let's try to prove it. Now looking at the given information, we know that BP equals QC and IB equals IC midpoint effect. And we notice that IP is in fact IB minus BP, and IQ is equal to IC minus QC, segment subtraction. And by transitivity, since these two segments are equal and these two segments are equal, their difference is equal, and these two segments will be equal by transitivity. So proof, IP is equal to IB minus BP, segment subtraction, and IQ is equal to IC minus QC, segment subtraction. Since IB equals IC midpoint effect and BP equals CQ, it's given, then IP equals IQ, because their difference here, they are equal to the same quantity. Then IP equals IQ by transitivity, and as a result, I is the midpoint of segment PQ. Now question 2, the perpendicular at P and Q to BC. So we need to draw the perpendicular to BC at P and at Q using our set square. Cut AB at M. When we draw the perpendicular, it will cut AB at M. And here it should be AC. The perpendicular to BC will cut AC at point N, respectively. So let's draw the perpendicular to BC at P. It will cut AB at point M, and the perpendicular to BC at Q will cut AC at point N. Prove that BM equals CN. Prove, underline BM equals CN. BM and CN, are they equal? Let's try to prove it. Here, to prove that these two segments are equal, let's try to find two triangles where BM is a side of the first triangle and CN is a side of the second triangle, and prove that these two triangles are congruent, and then as a result BM and CN will be equal as corresponding elements. So BM is a side of triangle BPM and CN is a side of triangle CQN. Let's try to prove that they are equal. So in fact they have BP equals QC, it's given. Angle BPM equals angle CQN equals 90 degrees, perpendicular effect. Let's see, what about the side? Can we say anything about PM and QN? No information are given. We cannot claim that they are equal. Now, what about the second angle adjacent to BP and QC? So angles PBM is equal to angle QCN because they represent the base angles of this isosceles triangle ABC of vertex A. So we found our three evidence. So proof: in triangle BPM and CQN, BP equals QC, it's given. Angle BPM equals CQN equals 90 degrees, perpendicular effect, and angle MPB equals angle NCQ. Base angles of isosceles triangle ABC of vertex A are equal. So in fact, angle ABC and PBM, they are the same. So we can claim this evidence. Now the congruence statement. Triangles BBP and CQN are congruent by one equal side included between two equal angles. We use the first case. All their corresponding elements must be equal, in particular or namely BM equals CN. Now let's continue with question 3. Prove that triangle MIN is isosceles. Question 3. Prove underline MIN is isosceles. First, let's draw the triangle MIN by joining the 3 points M, I, and N. To prove that a triangle is isosceles, either we prove that it has two equal angles or two equal sides. Here we cannot say anything about the angles, so let's try to prove that the segments IM and IN are equal. And to do so, let's do as we did in question 2. Let's choose two triangles where IM is a side of the first triangle and IN is a side of the second triangle, and let's prove that they are congruent. Here, if you notice, IM is a side of triangle IPM. It's also a side of triangle IMB. So you can choose. Here we have more than one method. Let's choose the triangle IPM. IM is a side of triangle IPM, and IN is a side of triangle IQN. Let's try to prove if these two triangles are congruent. First, we can say that angle IPM equals IQN equals 90 degrees, perpendicular effect. We can also claim that IP equals IQ, midpoint effect. We proved it here, I midpoint of PQ. And we can also claim that PM equals QN. Isn't that right? Can we claim that PM equals QN? Yes, because here in question 2 we prove that triangle BPM and CQN are congruent and all their corresponding elements must be equal. Also, in particular, we can claim that PM equals QN. So here we prove that these two triangles have one equal angle included between two equal sides. We use the second case of congruence. So all the corresponding elements of these two congruent triangles are equal, namely IM equals IN, and as a result, triangle MIN is isosceles of vertex I having two equal sides IM and IN. Now let's write the proof. In triangles MIP and NIQ. First we have, or we can claim, angle MPI equals angle NQI perpendicular effect. The segment IP equals IQ midpoint effect. It's proved in part 1. And last, we can claim that MP equals NQ corresponding elements of congruent triangles BPM and CQN. Now let's write the congruence statement. Triangles MIP and NIQ are congruent by one equal angle included between two equal sides. All their corresponding elements must be equal, namely IM equals IN, and as a result, triangle MIN is isosceles of vertex I because it has two equal sides, IM equals IN. So this is the end of our video. After watching the solution, copy it on your math copybook. Thank you for watching.